Hello guys, so welcome back to our lecture 24. So in that short video, we're gonna compare based on the results that we got so far, common base to common emitter, okay? So, and of course summarize what the characteristics that we got. So number one, for our input is RE small. That's just for the circuit that we saw. Maybe for another circuit will be another expression, but still it will be in order of RE, still low. Okay, RE small. If we compare it for common emitter, it was R bar. So that's worse, we can say. Number two, RO, it was equal to RC. For common emitter, it was RC as well. So equivalent in that metric. Number three, AV naught. So AV naught is here beta RC over R pi. For common emitter, it was minus beta RC over R pi. So these are equal in magnitude. I mean the value 100, for example, but VO and VN are in phase. Here they are out of phase. Also, that's not a big advantage, but it is advantage. Number four, AV. AV for common base is beta RC parallel with RL over R pi. For common emitter, same, but minus. So they are equal, but again, the magnitude is, the phase shift is in phase. Number five, for GV, this is really interesting in two aspects that I'm gonna explain right now. For GV here is basically beta RC parallel RL over R pi, and let's write it in terms of R pi, just like what we did at the end. So the original is RE small over RE small plus R signal, but we know we substitute RE with its equivalent R pi over beta plus 1 IB. So this was beta RC parallel RL over R pi, and then here R pi over R pi plus beta plus 1 R signal. And that's really, less than. This is, let's write it on another, So G for common emitter, it was beta minus RC parallel RL over R pi. Then here it was R pi over R pi plus R signal. So three observations here. Number one, in phase. The output and the input are in phase. Okay. Number two, the gain is less. GV for common base is less than GV for common emitter. Why? Because R pi over R pi plus R signal is bigger than R pi over R pi plus beta plus 1 R signal. That's very clear. The denominator here is bigger than here, so the overall ratio would be less. Or you can say that R signal effect, bad effect of course, is beta plus 1 times its effect in common emitter amplifier. Number three, and this is really important, and I didn't mention in the previous video. Most of these I mentioned, but this one I didn't. So the sensitivity now to beta. We studied before that for common emitter amplifiers, the gains are sensitive to beta. Just look at the, look at the common emitter here, GV. It's beta multiplied by something. If beta increased by 20%, GV will increase by 20%. If beta decreased by 20%, GV will decrease by 20%. Okay, it's directly proportional to beta. But here, let's look at GV for common base and try to guess the relation or the sensitivity to beta. Let's look at, you know, this expression here. So beta RC parallel RL over R pi over R pi plus beta plus 1 R signal. R pi can go with R pi. Okay, so this will be beta RC parallel RL over R pi plus beta plus 1 R signal. And look at that. You have beta here in the numerator and beta in the denominator. So if it increases in the numerator, it will increase as well at the same time, of course, in the denominator. So somehow the effect will be balanced. I mean, the numerator and the denominator are increasing at the same time. So the overall change will be less, not like the common emitter. And that's really advantage for the common base. So this is less sensitive to beta changes, which is good. So here it's better. So worse are input, equivalent RO, equivalent magnitude of AV, AV naught, but better in terms of there is no phase shift. And finally, in terms of GV, it's less in magnitude, but more stable than common emitter amplifier. Okay, guys, that was basically a short video to compare, you know, both and highlight the, you know, the advantage of GV as its insensitivity to beta. Thank you very much for watching this video and see you in the next video. Bye-bye.